Okay, so what we want to do first is go over some things we call identities. You may remember in geometry when you did proofs you had theorems. These are like our theorems, but they're not theorems in words, they're identities. Okay? And identities just mean a rule. And I'm going to give you some easy ways to remember these identities, because some of them you're going to have to memorize. All right, now do you guys remember that cotangent is the same as 1 over tangent? So this is a part of information we've already done that you need to know. But these are the reciprocals. So what do you think happens when I multiply two reciprocals together? Like, what's 2/3 times 3/2? 1. Okay? Do you think that always happens when you multiply reciprocals together?
Depending on...
Yeah. What's the reciprocal of 5? 1 over 5. So what happens when you multiply those two things together? You get 1. So tangent x times cotangent x equals 1. So in the future, when we start seeing something like that, we can replace it with a 1. That's why it's useful. Because 1 is a lot simpler than tan times cotan. Okay? We also know that cosecant is the reciprocal of sine, right? So what happens when you multiply those two things together? You get 1. See the pattern here? Secant is the reciprocal of cosine. So when you multiply cosine times secant, you get 1. All right. Tangent. We talked about this when we graphed tangent, but you may not remember it. Tangent by identity, by its own identity, is equal to sine divided by cosine. Okay, we used this when we were graphing. So in the future, when we see sine x over cosine x, we might want to replace it with tan x because they mean the same thing. All right, look what happens with tan and cotan. How are tangent and cotangent related?
One is an arc sine.
So we're actually not, let me tell you this, we're not going to deal with arc or inverse at all for this whole chapter, which is the best news. But I think what you're thinking of is reciprocal. So what we're doing is we're flipping these things upside down, right? To go from tangent to cotangent, you're flipping it. You're taking the reciprocal. So see how it was sine over cosine? Now it's cosine over sine. And we use that to help us graph cotangent. So you've actually seen that before, but I'm reviewing it. So if you forgot, there it is. Okay? And so we're just building up lots of identities. And now we're going to do our very first proof. Okay? And you're going to see how hard, I'm using air quotes here sarcastically, these proofs are. They're really not that hard. They're not hard at all. Okay, so if I want to prove that tan x equals secant x divided by cosecant x, what I really want to do is start with the most complicated side and see if I can replace it, like translate it into something else. So I'm going to start with secant over cosecant. Okay, what is secant the same as? We can just look up here if we're not sure. Secant is the same as 1 over cosine. So watch what I'm going to do here. I'm going to say 1 over cosine x all over. Okay, so that's the top of the fraction. Secant x is 1 over cosine x. What's cosecant x the same as? 1 over sine x. And I'm just using the identities right up from up here. So I replace cosecant with 1 over sine x. All right, so I have a fraction divided by a fraction. So how do we divide fractions? I'm going to give you a hint here. We multiply by the reciprocal. So if I want to divide by 1 over sine, that's the same thing as multiplying sine over 1. And when you have fractions like this, you can just do 1 times sine, that's sine x. Cosine x times 1, that's cosine x. And the good thing about identities is we can use any of these identities. So do you see sine x over cosine x anywhere up here? Right here. It is equal to what? Tan x. And that's what I was trying to prove. Okay, see? I wanted to end up with tan x. So this is like translating from one language to another until you get to the end. We proved that these two things are equal to each other. By starting with one, we used the identities we knew, and we ended with the other one. Okay, so that was the very first one we've done. What do you guys think? Not too bad.
End up getting to a point where we just kind of memorize, oh, this is equal to.
Definitely, if you know the identities, that's better. But like I said, right now, today, I don't want you to be focused on memorizing them. Today, we're just learning what they are and how to use them. We're definitely going to get to, I'm going to show you how to, I'm going to give you some really neat tools on how to remember them. So the answer is all the work. The answer is when you get down to tan x, you finish. So you can put a check mark. You can put actually this little thing called QED. I wasn't going to show you all this today, but I might as well. This is Latin, and I can never remember exactly how to say it, but it just means we did what we said we were going to do. We showed what we said we were going to show. And so like in the olden days, when they were doing proofs, when they got to an end of a proof, they wrote QED, saying we proved it. Okay, you don't have to write that. Really, most of you are going to just do a check saying, okay, I finished. Good job. Go me. Okay, so let's look at B. Here's another identity we're going to have. All right, but we got to prove it. Okay, because we're just going to practice that. So again, start with the more complicated side. It's always easier to start with the more complicated side and kind of work from there. So think about what I did in the previous problem. Do you have an idea of what we could do here? We could replace cosecant x with what? 1 over sine x. So let's do that. And what could we replace secant x with? 1 over cosine x. And now I have the exact same situation as I did a second ago where I have a fraction divided by another fraction. So I could do 1 over sine x times, if I want to divide by 1 over cosine, I'm going to multiply by cosine over 1. Dividing a fraction is multiplying by its reciprocal. And so now to multiply these, I would just do 1 times cosine x. That's cosine x. Sine x times 1, that's sine x. And do we have an identity that tells us what cosine x over sine x equals? Cotangent x, right there. Which is what we wanted to prove that it equaled. Okay, so we did it. Okay, so that's what a trig proof is.
We have to add
You need to write the x every time. I know it seems like it's not a big deal, but you just need to do it. Is anybody thinking we could have done this a different way?
No.
Because there is another way. Well, and that's okay if it's okay if you didn't see it, and it's okay if you saw it. What would happen, like, do you guys see how, look what happened here. Tan x equals secant x over cosecant x. What's just happening here? We're just flipping it upside down. So we could have used that strategy to prove it. All right, so up here in your notes, I want you to go ahead and write equals equals. So we now know that tan x, we already knew that it equals sine over cosine. We now know that tan also equals secant x over cosecant x. And so here's another identity. Cotangent x, we already knew that cosine x over sine x equaled it. Now we know that cosecant x over secant x also is equal. Okay, I want you to draw a hexagon. How many sides does a hexagon have?
6. 5. No, that's a pentagon.
Definitely
It's
6.
6.
So mine's not perfect. Yours isn't going to be perfect either. It's 6. About this size is good. In this hexagon, we're going to draw a lot.
Ooh.
Okay, so you're going to get better at it next time. Today's the first time. Okay, now, do you remember the order in which we learned signs and all that stuff? Didn't we start with sine? And so go ahead and put sine up here at the top, right here. And then after that, we learned cosine. Then we learned tangent. And it is important that you write it the specific way. And we learned about the reciprocals. So across from tangent, I want you to write cotangent, x. And then what do you think goes down here? Secant x and cosecant x. This is a little trick. And I want you to write a 1 and circle it in the very middle. Okay. I want to run through our identities and then we're going to do some more examples. Look at, let's take sine. What is diagonal to sine? Cosecant, the reciprocal. See how they're diagonals? What happens when you multiply sine times cosecant again? You get 1. That's why there's a 1 in the middle. Okay, this is just starting. There's some more stuff. I know your mind is not blown yet, but it will be in a minute. Okay, cosine and secant, those are reciprocals. When you multiply them, you get 1. Tangent and cotangent, when you multiply them, you get 1. Okay, so that's one way this trig hexagon works. All right, now, remember how I said tan x equals sine over cosine? Okay, look right here. If we start with tan, and I go this way, you see how it says tan x equals sine divided by cosine. Okay, if we go this way, tan x equals secant divided by cosecant. This is a way to help you remember the identities. In the end, some of you are just going to memorize, and some of you are going to want something like this. Okay? We could do the same thing for cotangent. Watch this. We start with cotangent. We go counterclockwise. Or I guess that's I don't know what I'm saying. Counterclockwise, yeah. Cotangent x equals cosine divided by sine. Cotangent also equals cosecant divided by secant. Okay? And that's not the end of the trig hexagon, but that's where I'm going to leave it for now. All right. So let's do this example. It says, which of the following is equivalent to cotangent? So this is really not a proof, but can you see any of these that you know is not equivalent to cotangent? A. What is A equivalent to? Secant. A is secant x, therefore it is not the answer. B is equivalent to tangent, so B is not the answer. Okay, so secant x over cosecant x, that's also tangent. If those two were flipped, that would be my answer, but they're not, so we got to get rid of them. Now, look at what I have left. Okay, one thing I want to point out is when you see sine squared x, that's the same thing as sine times sine x. Okay, so I want you to scratch out sine squared, and I want you to write in its place sine x times sine x. All right. And we're multiplying that to cosecant. Sine x times cosecant is a 1, so we're going to do like that to cancel them out. And look at what we have left. Cosine x over sine x. Look up at your identities. What is cosine x over sine x equal to? Cotangent. So, this is your answer. Okay, I want to show you what happens with E. And here's another thing. Instead of writing it down twice, what you could do, watch what I'm going to do here. You could just cross off the 2 and just write one of them. That would work as well. It's the same idea. Here, cosine x times secant, those are reciprocals. So they make a 1, so we can just cross them off like that. What do I have left on E? Sine x divided by cosine x. Do you see that identity? That's tangent x. So this is going to help us. We're building our case here to do proofs. All right, now we're going to write 3 expressions that are equivalent to sine. Okay, I want everybody to try to write 3, and you may come up with different ones. And you may have a hard time coming up with 3, but you should be able to come up with, for sure, 1, at least 2. So everybody try this one on their own. Okay, did anybody come up with 1 yet? I know you're not done yet. 1 over cosecant is an answer. Now, did we have this as an identity up there? Exactly, written this way. No. What we had was cosecant equals 1 over sine. It just means take the reciprocal. Think of it this way. If sine x times cosecant x equals 1, and if I wanted to get sine x by itself, what would I do to both sides?
You divide by CSC.
Exactly. So that's another way of getting this. So this thing is equivalent to sine x. Did anybody come up with something else? What'd you get?
Oh, so now
Cos times tan.
yeah, I think cosine over cotangent.
Okay, so let's do this one first. So cosine x times tan x. What made you think of using that one, by the way? What made you think of using that one?
That's what those tangent equals sin x over cos x.
Okay, so the fact that tangent x is sine x over cosine x, the cosines would cancel and you would just be left with sine. Here's another way of thinking that may be or may not be how you thought of it. Here's something else. Let me write down what the identity is. Let me tell you, there is on all these always going to be pretty much more than one way to think of a problem. So think about the identity that we have here in blue. If I wanted to just get sine by itself, what would I do with this cosine? Times it to both sides, right? So I would multiply cosine x to that other side, and that's that right there.
After you find one solution, you just basically try and find something that's equivalent to the next. So
Yeah.
Then
You can go back to what's equivalent to sine x, or you could say, well, what's equivalent to this now? Okay, Clayton, what was the other one you said?
Sine equals cosine over tan cotangent.
Okay, so let's try this one. This is a hard one to come up with, I think.
I got that
We
one.
just flip the.
So if we kind of go back up to cotangent x equals cosine over sine, just for, let me write this down here.
Oh, and then he put what sine equals at the bottom.
Watch this. So here's our identity. Okay, if we want to get sine to the other side,
Times it and divide.
we need to times the sine to the other side. And then if we want to get cotangent to the other side, we need to divide by it. Okay, for some of you, you got this as so easy for you just the way your brain works. Okay, for some of you, you're struggling right now. It's not easy yet. I promise it will get a lot easier. We just got to look at it all sorts of ways. Okay, so turn the page. That was a very open-ended way. That was a very open-ended way of me asking that. So what we're really going to be more doing is I'm going to tell you, transform this into this. Okay, it's a little bit more black and white. It's not so open-ended. Okay, so look at A. It says transform sine x times cotangent x into cosine x. So this is how I want everybody to write this. I want you to start by rewriting what they told you to start with. They're telling you start with this and transform it into cosine. So I'm going to start with this and I'm going to write equals. And I'm going to write something and then I'm going to transform that a little bit. And in the end, what am I going to write? Equals, hopefully end up with cosine x. That's what a trig proof is. So what you want to do is you want to rewrite part of this. Don't change everything, but rewrite part of it. So let's rewrite cotangent. Now we have two options for cotangent. We have cosine over sine, and then we also have cosecant over secant. Since I want to change it into a cosine, let's use that identity. Okay, and you may need to kind of flip your paper back and forth to keep looking at the identities. You're definitely going to want to have your identities out when you're doing your homework. So let's replace this with this. One of the identities for cotangent x is cosine x over sine x. Okay, equals. Now, algebraically, sine x is the same thing, and this is what you guys were kind of asking me earlier. It's like saying over 1, if that helps you to put the over 1 there. So if I want to combine these into one fraction, it would look like this.
Wouldn't it need to be squared?
You can. There's certain steps that I'm showing just to make sure that everybody really understands what's happening here. Okay. Now I have a single fraction. This sine x and this sine x, what happens when you divide something by itself? They cancel each other out. Now, next time, if you saw that in the previous step and went like that, that's okay too. And so what do we end up left with?
Cosine x.
Cosine x. Isn't that what I wanted to be left with?
Yes.
Yes. So we put a check mark and we say, good for us, we did it. We transformed this thing into that thing. And that's a trig proof. Okay, you're not having to quote theorems, anything like that. So it's actually, I think, a lot better than geometry proofs. All right, so let's look at the next. Lauren?
So the little hexagon thing you drew, are those identities too?
Yeah, it's just another way of representing the identities and helping you remember them. And I'm going to talk about the hexagon a little bit each day. Okay, so let's look at the next one. It told us to start with this. Eventually, I'm going to let you start with either one, but you're going to start with the one they're telling you to start with. So I'm circling it, and then look what I'm going to do. I'm going to rewrite it exactly as it is, because what I'm not asking you to do is tell me what this equals. Like, I'm not saying, what does this equal? I'm saying it equals cotan x. So at the very end of the problem, don't write this down yet, but at the end of the problem, I know you're going to have this. So what your answer is all the work. So you have to be really careful and make sure that your work is good. That's the thing about proofs you have to be careful about. All right. Now, watch what I'm going to do here. See where it says sine squared x? I'm going to write that as sine x times sine x, because that's what that thing means. Okay, I get that the squared is kind of in between sine and x. It still means square the whole thing. And then just rewrite the other things. Don't try to change too much in one step. All right, now do you see something easy on the bottom that simplifies?
Sine and cosecant.
Yeah, what is sine times cosecant? A 1. So I can cancel that out, and you can write a 1 in its place, or you don't have to, because it's an identity. One of the identities on the front was that sine x times cosecant x is 1, and that's because they're reciprocals. That's how we know that.
Is that something that we just need to memorize?
For this is what I was saying before. For today, just look them up. As we use them, you're going to memorize them, and I'm going to help you with that. But today, we're just looking them up. Okay, so look at what I have here, and look at what I'm trying to go for. We have a couple of options here. We can try to transform 1 over sine, or we can try to transform 1 over secant. You could do it either way. Honestly, I don't think one is easier than the other. Okay? So let's think about this. 1 maybe over sine. What is 1 over sine x? What is this? What is the reciprocal of sine x? It is cosecant x. 1 over sine x is the same as cosecant x. And see how I'm putting it in the numerator? And I'm leaving secant in the denominator where it was. I'm not moving that yet. Okay. Cosecant x over secant x. That's an identity. See if you can find it on the front.
Cotangent?
It is cotangent. And isn't that what I was trying to prove?
Yeah.
So I underline, I'm like, good, I did it.
Wait, but what about the second secant for the last secant?
What about it?
What do you mean?
It's in the denominator. I put it in the denominator. One of the identities for cotangent is cosecant x over secant x.
So when you did the
It was this one right here.
1 over sine, and we transform that into secant, right?
Yes,
Shouldn't it go on top though?
it did.
Or no, excuse me, shouldn't it stay on the bottom?
No, because you're only going to put things on the bottom that are already on the bottom. Like, this is a great question. So let me show you what we could have done over here. We could have done this. Okay, I could have just said it's not in the top or the bottom, right? Are you okay with that?
Yeah.
Okay, so anything that doesn't have a denominator is really over 1. And so, see, it makes it more clear that cosecant x is in the numerator. So these are great questions. Yes.
I solved it a different way.
How'd you solve it?
Instead of putting just 1 over everything, I've changed it to cos times c SEC, and then just cancel out the SEC, the other one.
Okay, so you started with kind of the secant in the denominator, made it into a cosine,
Yeah.
and worked from there.
I did that cos over sin, which is CO2.
Yeah, that works. There's always on these going to definitely be more than one way, and sometimes y'all are going to be like, Miss Brooks, you're solving this the harder way. And sometimes that's opinion, and sometimes you might be right. Sometimes I am doing it the harder way. Okay, so look at this is a good segue into the next thing. Now we're going to do a proof, and we're going to do it 2 different ways. Okay, so first we have sine x times secant x. Remember, your first step is just rewriting it. Just rewrite it. Like, look, on a quiz, that gets you something if you just rewrite it. So it's a good habit to get into. Okay, now in the end, what do we want to transform it into? A 1. We want equals 1 at the end. So I want lots of stuff to cancel. My personal way that I like doing this is to try to like get these things back into sines and cosines and then try to get something to cancel. So I'm going to leave the sine x alone. Okay, so I'm going to make the secant x into 1 over cosine x. And keep in mind, we're going to do this a different way in a minute. So if you were like, I would do this differently, I'm going to ask for your opinion here in a second. And then what would cotangent x be in terms of sine and cosine? Which one?
Over sine.
Cosine over sine. And look what happens. See this sine x? Isn't that like a little over 1? Now I could rewrite all this, or look at what we could do. We could just like extend the fraction line.
They're really hard to do.
So look, sine x over sine x. Sine divided by sine, that cancels. Right? When something's on the top and something's on the bottom, they're going to cancel. What else cancels? Cosine. Okay, make sure when you're doing this, by the way, that you're not scratching it out so much that I can't read what you've written. Because I need to be able to tell, like, what you did. Because remember, your answer here is this work. Is that what you did?
No, but I can just see myself doing that, so that I get it over.
Yeah. Because in the end, when I grade this, I know what you're supposed to start and stop with. What I'm really grading is, did they figure out why?
So you could just write and like scratch it like.
No, what I'm saying is you won't get the credit if you do that.
I'm kidding.
But yes, People try to do that. Or people are like, I did it in my head. I'm like, nope. Okay, let's try this a different way. Okay, anybody have an idea of something else I could have done here?
Burger?
Could you,
This is your time to show up.
flip it so that it was, secant, or cosecant over secant?
For the cotangent?
Yeah, for the cosecant.
Okay, so you're saying leave this both of these how they are, and then make this cosecant x over secant x. Yes? No, I like this. Okay, now, are we okay with just putting over ones? I think that kind of makes it easier to see clearly what's on the top and what's on the bottom. Okay, what easily cancels? The secant here, and I'm going to go ahead and add in this step. Just write down what we have. Your goal here should not be, what is the least amount I can write and get full credit? That's not a good goal. That's going to mess you up at some point. All right, so I just crossed off the secants. Now look, I have sine x times cosecant x. That's an identity. It equals 1. And there's even more. There's more than 2 ways to do this. But I just wanted to show you. You may be doing it one way and someone else may be doing it another way, which makes it a lot of fun for me to grade.